By the end of this lesson, you should be able to plot and interpret velocity-time graphs, determine distance, displacement, velocity, and acceleration from a velocity-time graph, deduce information from the shape of a velocity-time graph. Do you remember this man? In the last lesson, we plotted a displacement versus time graph for the motion of this man. The man jogs with a uniform velocity of 2 meters per second. From this information, we can draw a velocity versus time graph for the motion of this man. What do you mean when you say that the man is jogging with a uniform velocity of 2 meters per second? Let us now plot the velocity versus time graph of this man. Click on the play button. Let us analyze this velocity versus time graph. The slope of displacement versus time graph gives us velocity. What does the slope of velocity-time graph give us? Click the Graph Analysis button. The slope of the velocity-time graph represents the acceleration of an object. The slope of the graph is 0, and hence the man jogs with 0 acceleration all the way until the end. Do you know that from the velocity-time graph, we can get the length of the track, which is 50 meters? How do we get that? The area under the velocity-time graph represents the displacement traveled by the man. Let us now analyze some other velocity versus time graphs. Click the Situation 1 button. Describe the motion of the car. The car moves with a uniform acceleration of 1 meter per second squared. The distance traveled by the car is 450 meters. The displacement of the car is 450 meters. How can you describe the motion of the car? For the first 15 seconds, the velocity of the car is increasing and the car moves with a uniform acceleration of 2 meters per second squared. After the 15th second, the velocity of the car is decreasing. The car moves with a uniform deceleration of 2 meters per second squared. The car stops at the time of 30 seconds. The distance traveled by the car is 450 meters. The displacement of the car is 450 meters. How do you describe the motion of the car? The car moves with a uniform deceleration of 1.5 meters per second squared for 30 seconds. After 20 seconds, the car has a negative velocity. That is, the car moves in the opposite direction. The distance traveled by the car is 375 meters. The displacement of the car is 225 meters. Let us see the motion of a car according to the graph given. The car moves with a uniform acceleration of 3 meters per second squared for 10 seconds. After that, The car moves with a uniform velocity of 30 meters per second for 5 seconds. The car starts to decelerate for 5 meters per second squared for 10 seconds.